This is always the hardest slot after lunch. So what I decided to do is not to use any slides and just talk a little bit. And I chose the topic, why do we need a new design? Because I think most people here, probably from my guess, are somehow engaged into building equipment, building hardware, CPU, or data center design, or something in that nature. Therefore, what I thought, most of the times when we're talking to anybody in this ODM, OEM industry, everybody's saying, well, who is the customer? Who is buying this stuff? Why are we building it? And who needs what? So I thought maybe the best thing to do is to be the customer. We are the customer for most of the equipment that people are making. We're the ones who buy it, deploy it, install it, and automate it. And therefore, this would be maybe an opportunity for anybody to ask questions that they want to ask from a customer about what do they need or what's the business plan and why. So first of all, let me tell you a little bit about what we see happening, because we also have customers ourselves. And I want to tell you a little bit what we see from our customers and why we're deploying edge equipment and why we're innovating on all these hardware and software platforms. So what we see today is that people are building two sorts of applications. Some people are building cloud-native applications that can auto-scale, mostly containerized platforms. And what they do is they're trying to build it as hardware agnostic, cloud agnostic. That's what most people are trying to do, is to create all these applications so they could use Google, Amazon, Microsoft, or any cloud. And also, they don't want to know what the hardware is behind it. And they don't care what CPU, they don't care. It's almost like it's designed so that it doesn't matter what cloud and what hardware, because that's very cost effective, very efficient from a developer perspective. You can take that application and put it anywhere. And when you see things like Kubernetes and what they've done for portability between clouds and environments, you know, the whole software world has gone in that direction. So a lot of people talk about this. It's the commoditization of hardware, of data centers, of cloud. What we see, though, is another set of customers where we sit in the place, we're building a different type of cloud. The cloud we're building as Packet is more about the choice. People get the choice of hardware and the choice of software platform. And therefore, we're getting a completely different set of users that actually care about what the hardware is, what the software platforms, as well as what's the location where we're putting our platform. And my view is that this is what the whole industry will look like in the next 5 to 10 years. Everything is going to be cloud. Nothing other than cloud will probably make it, including networking will all become cloud, as we started to hear about in 5G. And I think you'll have two types of clouds. I would say the centralized cloud that can scale enormously, that the big hyperscalers are building, and those clouds are designed to have very high availability for the application. So they have an availability zone with multiple data centers, massive, 100 megawatts, 140 megawatts data centers, multiple of them with fiber. And then you're going to have a lot of stuff get closer to the edge outside these centralized locations where people say, hey, I really want my choice of GPU, or I want to build my application for this specific CPU type, or I want to do 5G or wireless. I want to program the equipment. I want to know physically where it is. I want to do lower latency, high throughput. And we have seen tremendous demand for that cloud that we're building. Because in general, there's a lot of software. Most people are saying, I'm no longer in hardware. I'm just going to build software apps. But then there's no cloud that is native, that is really thin, without a big software layer on top of it that people will use. So what is the killer application people are looking for? I would say the biggest application we see so far is network. Network has gone completely virtualized, and network really cares about controlling how many NIC cards, what's the capacity, how you can automate and virtualize, and how you scale. So networking, virtual EPCs, and then P gateways are probably the biggest thing we see today. And many new networks today that you haven't seen before. So when you look at something like private LTE, which is CBRS, the 3.5 gigahertz shared spectrum. The stats that came out of what people are using, 86% of the people deploying this new wireless network are not telcos today. So that gives you a sense of how many people are now into the network space that were not telcos. And so all these guys have these EPCs that require very high performance hardware that need to program it to specific CPUs, and they want to distribute it everywhere. And we are spending a lot of time with them because this is really critical to create an edge. You really have to have a very low latency and programmable last mile. Then what we see is that if you're building an edge platform, an IoT specifically, the biggest requirement we see is people want to connect to the IoT and edge platforms of the big clouds. So this is probably what the edge, in my opinion, looks like. How do the different IoT platforms and all these software layers that exist in any specific city or market can connect to each other? And that is an emerging field. It's really important because the volume of data is so enormous, you really cannot move it to some other city. You want to keep it locally, and you want to act on it quickly. So what we are doing is we're moving from the 20 locations that we have today only. We're going to extend our cloud to 50 more locations. So we're going to get to 70 locations globally the next 12 months to 18 months. As part of that move, we're creating a new model where we're going to deploy our edge compute at cell towers. We're working with multiple of them today. And that requires a fully automated operational model, zero touch, because you really can't, you don't have the same resources you have at data centers. We will also deploy at data centers, just for clarification. But we feel that between creation of new cell tower locations and data centers and being able to bring diversity of hardware between multiple CPU options, multiple GPU options, storage, SSD, as well as eventually open networking, including the wireless component I talked about, then people will have the pieces that they need to start to build the application locally to take advantage of the massive amount of data and the low latency. I am surprised how fast this is moving compared to what I thought would happen. So for example, you heard from Sprint before. They are moving with a very innovative IoT model that completely disaggregates the wireless network in a very positive way. I personally would have predicted we would see that in 2020. But the reason people are doing it is because enterprise customers have all moved to the cloud, and IoT is really taking hold enormously at the edge. I see enormous potential, or we see enormous potential in things like super NICs and a lot of the technology that starts to distribute networking more than just a switch, because that opens up huge amount of immediate capacity and very low latency between storage, compute, and also locally for connectivity. And so my perspective is that maybe 2 years from now, we'll have 10 times the throughput on those devices at the edge as we would have even in the core, despite just because of the volume of data that exists at the edge. So that's our perspective. I just wanted to share it with you. I didn't want to go into any more hardware design, boxes, cables, or who's what and where. I just wanted to tell you what people are using, and I feel that the networking piece alone is going to drive everything else. Networking is one of the biggest investment area anywhere, and availability of cloud and I want to say ODM type hardware at the edge has not been possible before. Therefore, I feel like this is going to open up enormous amount of innovation. So this is what I had. I can go into many topics more, but I thought maybe I will open it up for questions. We used some of the times from my presentation for the panel before, and I was very happy with that because I intended to just chat, and it's after lunch. So anybody would like me to expand on any topic or anything? Anybody has a question? This is your time to ask a customer. So nobody should leave here saying, we don't know what they want. Please?
For your new locations you're looking to deploy, are you
Yeah, for the question is for our new location we're deploying, are we using Open19? I would say we have gone to everybody, as you saw from Tao, asking for Open19 availability. Clearly, from our perspective, it's not ready for deployment today, but that's what we would like. We would like to be able, for us, Open19 solves one piece of the puzzle, which is the form factor cabling. That's one piece for us. We're still designing how the servers look. We're looking at microservers. We're looking at how do we do NIC aggregation, what do we do with NVMe and SSD, but the form factor of Open19 and the ability to operationalize the model is something we like. I honestly can tell everybody here that I don't feel there's a lot of availability. There are a couple of people here who make it. Definitely Flex is leading the charge, but it's not widely available in the volume today. But that's what we want. So we're starting with standard 19-inch until we see what happens next. And so just to add to it, this is not like the way Open19 is designed, it's a form factor, as I said before. So just solving the form sometimes is one. Even if it's available, we still have a lot more requirements of how the server looks, what CPU, what do we need to do. That may take a lot more time to innovate on. Yep. Yeah. Yeah, I mean, perfect. So the question is, what do we see in terms of cost savings with Open19 or what we experience? I would say we have two objectives with Open19. One is the ability to get more hardware options in the hands of customers. And a lot of you make specialized hardwares here today. So we would like to, if we have a form factor that we can ship and put anywhere, and people have the ability to put it in an Open19 form factor, then we see that the hardware innovators can take charge and say, here's my hardware, it's Open19 ready. Then all the discussion becomes, how do we do go-to-market, integrate the API, the software, the delivery, and then what's the volume we want to buy? Today, that's not the situation. Today, it's a much harder thing to do, and where do you fit it and how you do it, and then, therefore, you buy much smaller volume because it's not portable, and it's not easy to use. So that's our number one objective is that. And the locations we're going to don't have very high level of expertise sometimes in technology, so it has to be almost touch-free operations. The second objective is being able to bring the ODM model into our world, and I think the savings is very substantial. So we see tremendous reduction. The savings is not a discount, it's more of a technology innovation savings. So for example, being able to use microservers, because we can do it in Open19, is a huge benefit to a lot of our customers. So this is kind of how we see it. If you think of where the world is going in the future, where even the eNode Bs that exist at cell towers need to go to edge compute at some point, which is millions of devices, there's no way to do it without a new form factor. So that's kind of how the model is going to go. That's why we're starting with the standard 19-inch, because we want to bring those benefits while we wait on a better operational model. And we are going to contribute we're going to continue to modify, as you saw, and contribute our learnings and our innovation back to the community. SDN or? Yeah. Yeah, I think software, we were talking about this before. So when it comes to networking, and a lot of few people have asked me about networking, the big issue of networking is really not the hardware. The real issue with networking is the software. And today, if, for example, we're a big Juniper shop, we buy everything from Juniper for the Tor and switches. We like the product, it's very good. We have to, at some point, introduce different diverse switching and hardware options that people are asking us to do. But when you go to that, you really have to now introduce a software stack for networking. SDN is one piece of it, but I think it's more like open networking in general. my best way to describe the future networking is I call it bare metal networking, which is, it's no longer a box. Now you have bare metal switches with all the pieces disaggregated even inside the server, and the networking becomes fully distributed within the rack, and you need the software to enable it and automate it. So I don't think the industry has many solutions. The big hyperscalers solve those issues, but solve it inside the cloud. But with our model being open to any software, hardware, that's probably one of the biggest challenges we're going to start to tackle soon. That's slowing down some of the adoption of some of the networking products that a lot of people are pushing, especially super NICs for us. I can take one more, I think. So maybe some feedback, not a question. Does somebody have an opinion on something? This is a good chance. Yep.
Maybe just some comments given your past experience. Is this the new peering opportunity? Is this the new meeting room? Does that all move to the edge?
Yeah, this is a good question. So based on my previous experience when I was a CTO at Equinix, and there, as you know, I innovated a lot on Cloud Exchange and other stuff, which became the new Meet Me Room per se. Is the Meet Me Room moving to the edge? I think there's a new Meet Me Room coming up. I definitely think the exchange at the core is not going to stop, because what happens in the core data centers is all the capacity between the multiple clouds is being exchanged. Lots of data between Google, Microsoft, Amazon, Equinix, many customers, and that will continue to be significantly exchanged in the major data centers. But there's a whole new set of data that's not being exchanged today. This is what we think will be able, a lot of us call from Vapor.io, many others, which is enormous data at the IoT ecosystem. So multiple IoT platforms exist in every market, and that's a new mode of exchange that's going to happen. And they need enormous capacity because a lot of data is being collected locally. So think of it as IoT exchange is my word for it. Between IoT and 5G platform at the edge is what's going to happen, in addition to the exchange between the major clouds and networks that happens today. Yep.
So going back to your background at Tarazi, how do you see the position or role of the network operations team in this bare metal hosting environment?
This is probably an excellent question. I agree. So back to my Verizon days, what do I see the role of the operations team when we get to bare metal networking and cloud as we have today? I think most networks, and not commenting on any specific telcos, but every telco has the same challenge, which is this new platform is an IT-based platform, software stack, and it's not a network stack anymore. So therefore, the skill set is definitely different. The tools are different, the automation is different. And the need, I think the challenges will start to show up in multiple areas. The first one, by far, is openness, I say. By design, most telcos design the network as closed for security, and just this is how it is. This is how we've all done it. IoT and all these new platforms are open platforms that need to interact with other software and clouds, and the data is all over the place. So I would say the biggest challenge most networks start with is openness. Customers are not going to buy your enterprise service if they can't do hybrid cloud with Azure or hybrid cloud with Google Cloud or AWS, where all the data is. So that's probably the first thing people face, and that is a tremendous challenge from an operations perspective. How do you maintain security, but you provide that interconnection, and different people have dealt with it in different ways. I would say the second one is most of them want to reduce the cost by using white box switching or generic compute, and that requires a new software stack. So you saw that some of them are contributing the software stacks to the Linux Foundation. What I've seen is the Linux Foundation stepped up to be the software platform for the telcos for that, and I think that will continue, and we're ourselves active with the Linux Foundation. The third piece is that you have to have an API stack where everything is programmable, and that different people are gone in different ways to do this. You saw, I think, what Sprint is doing with the program. the curiosity is one way to create a new service model. And I would say the last one is you have to be able to add capacity very quickly. I mean, for example, our model is to be able to add server capacity in less than 5 days anywhere in the world. And if the capacity is already existing, people can provision it in 60 seconds anywhere in the world. So within 60 seconds, you can choose your server type, what CPU, what operating system you want on it in any of our data server centers, and you can activate it. And if we don't have the servers, we'll ship it and install it in 5 days. There's no way the traditional telco model keeps up with that. So that's what I would see. I'm not saying they're not solving it. They're definitely solving it in different ways. And the telcos have big advantages too. But most of them are building or buying that technology to make it happen.
Just a quick follow-up. So when VoIP came out, especially the wired network,
Yeah.
everyone said QoS isn't going to matter, right? They just want the cheap price. What is the analog to QoS?
Okay, very good. So the question was the analogy. What's the analogy to today's world from VoIP? When VoIP came up, it was all about QoS and how you maintain different service levels on the IP network. So if you didn't implement QoS on your IP network, you couldn't do VoIP because you couldn't reserve enough capacity for the voice traffic. I'm trying to think. I think what happens now is, I would call it interconnection is what's critical more than QoS. How do you create secure interconnection to the software platforms? And also, more importantly, how do you do CI/CD, which is continuous integration and delivery for the platforms your customers use? When I think of how people buy capacity from Packet, they use one of many software platforms. A lot of them are communities, like Terraform, et cetera. I think the new word would be, how do you integrate your platform with these open source software platforms that people use? So it's a form of interconnection or integration. That's new, because that's how the customers show up. Most customers for us use our platform as code, and it's not somebody, giving you an order. They just add code to the application, and our infrastructure is available and programmable. Okay, so I think with our last comment, I would say, just from a forward-looking picture, probably the biggest change we see is that because of the volume of data and analytics and all the stuff around AI and machine learning, the kind of physical infrastructure we're going to have at the edge will be significantly different than just traditional servers over time. And therefore, that requires complete disaggregation of the hardware as we see it today. So that's the next 5 to 10 years is what's going to happen. And this kind of community of innovators on hardware is going to be important. For those of you in this area, as you saw from Tao's presentation, we're going to have monthly hardware meetups. And in our Palo Alto office, we'll put some information on our web. And anybody who wants to chat about it or show new hardware, we're happy to engage. We think that's probably, we learn a lot, at least from people coming by. So we invite you to do it. We'll put the details on the web. If you happen to be in Silicon Valley and you want to pass by, just please come over. And I think that we have so many customers who've never seen the hardware who really want to see it. So we're thinking to put a stack, in our data centers and let people see it. Most people know it exists in some data center, and they have no access to a big hyperscaler data center. So we're thinking that may help a lot. Okay, thank you guys so much. Thanks for your time. Thank you.